Section 4. Today we are taking a look at solving a quadratic by this process called completing the square. So we've looked at solving quadratic by graphing, we've looked at solving a quadratic by using square roots. Today we're going to use this technique called completing the square. Before we jump into some examples, I just want to go back to a previous example that we've done, and this will hopefully help us kind of make a visual sense of what it means to complete a square. When we were asked to expand and find the product of x plus 4 squared, we expanded that and we said that that's x plus 4 times x plus 4. When we were first learning to multiply these binomials, we said one of the methods is to use this box method. And whenever we have this box, this rectangle here, where the dimensions are the same on both the height and the width, or the length and the width, then that would be considered a square. And the product here would be x times x, or x squared, 4 times x, which is 4x, another x times 4, 4x, and then finally 4 times 4 is 16. So we said that this was called a perfect square trinomial. And when we add up those like terms, we get x squared plus 8x plus 16. Now, it's perfect square trinomial, and the area of that perfect square is the sum of these three terms, which make up a quadratic. And so this is going to be kind of a visual representation of what we're trying to do today. If I were missing any one of these pieces, I would have an incomplete square. All right, so let's jump into our notes for today. So first of all, we're going to find an expression, x squared plus bx, and then we are going to try to complete its perfect square by adding in a constant c to this expression, so that x squared plus bx plus c is a perfect square trinomial, just like what we saw above. And this process is known as completing the square. So here are the steps. We're going to write our quadratic with just our quadratic term and its linear term. So that's just the two terms that have an x in them. Get those by themselves, such as x squared plus 8x. Next, we're going to take that b number, that number in front of my x, and then we are going to divide it in two and square it. That result is the c term. All right, so there's 8. 8 divided by 2 is 4. When we square 4, we get 16. So that's c. And now we're going to write that as our perfect square trinomial by adding c to that expression. So x squared plus bx plus half of b squared is our perfect square trinomial. And now we're going to factor that perfect square trinomial down into its two linear factors, which will turn out to be x plus b over 2 squared. So we have x squared plus 8x plus 16 gets factored back down into x plus 4 in parentheses squared. So when we do this completing the square process, we're working down the left-hand side to get back to this expression of x plus 4 squared. Earlier in the year, we went the opposite way. We started with the x plus 4 squared, we expanded it and multiplied it together to get that perfect square trinomial. So this is just the reverse process of that. Let's jump into a few examples. Let's complete the square and then factor the trinomial. All right, so we have x squared plus 18x. My b value here is 18. So I'm going to take half of that, which is 9, and square it. And that leads me to x squared plus 18x plus 9 squared, which is 81. So here's my perfect square trinomial, and now I'm going to factor it down. One way I can think about this is just factors of 81 that combine to be 18. Well, that is 9 and 9. So this gets factored down to x plus 9 times x plus 9, which is x plus 9 squared. And so we are doing this process of completing the square. Next up, we got x squared minus 20x. So my b value now is negative 20. If I take half of negative 20, that gives me negative 10, and negative 10 squared would give me 100. So x squared minus 20x plus 100 is my perfect square trinomial. I'm going to factor this down by looking at factors of 100 that add to be negative 20. Well, that's x minus 10 times x minus 10. And I can write that as x minus 10 quantity squared. Okay, so remember, we are learning how to complete the square in order to find the solutions to a quadratic equation. So in example 2, we're going to take this one step further, and we are now going to solve our quadratic equation by completing the square. So first and foremost, we are going to complete the square on the left-hand side, and you'll notice on the right-hand side I have another number here. We're just going to leave that over there. So we're going to take our b value, which is negative 16, divide that by 2, which is negative 8. Okay, that gives me x squared minus 16x, and then remember, negative 8 squared is going to be positive 64, is equal to negative 15. Now, what I do to one side of the equal sign, I have to do to the other side. In order to keep things balanced in algebra, you have to do like operations to both sides of that equal sign. So I added 64 to the left, I need to add 64 to the right. All right, now I'm going to rewrite this perfect square trinomial. This would be x minus 8 times x minus 8 is equal to negative 15 plus 64 combines to give me 49. All right, next up, I'm going to condense this down one step further. This is x minus 8 squared is equal to 49. All right, now you might start to see how this looks familiar to the things that we did yesterday. I have an expression squared is equal to 49, and now I'm going to undo them. I'm going to solve for x by taking the square root of both sides. And when I do that, I get x minus 8 equals positive and negative 7, which is the square root of 49. All right, now I'm going to have x minus 8 equals 7, x minus 8 equals negative 7. So adding 8 to both of those, my two solutions are 15 and positive 1. So here are my two solutions to the quadratic equation that I started off with, or the quadratic equation I started off with, 15 and positive 1. As always, you could take those and you could plug them back in, and you could check to make sure that that indeed does check out. All right, let's try example 2b. We are again going to complete the square in order to solve the quadratic equation. So I have my x squared and my x term by themselves. B is equal to 10. Half of 10 is 5. 5 squared is 25. So when I complete the square, I have x squared plus 10x plus 25 is equal to negative 5. Now I have to also add 25 to the right-hand side because I added it to the left as well. I'm going to condense this x squared plus 10x plus 25 down to x plus 5 times x plus 5, which again can be rewritten as x plus 5 squared, and that's going to be equal to 20. All right. Now we have our our expression here that is squared, set equal to 20, and we're going to solve for x by taking the square root of both sides. That gives me x plus 5 equals the positive square root of 20, and x plus 5 equals the negative square root of 20. Now 20 is not a perfect square here, so we'll just kind of leave it in this radical form. If we were to subtract the 5 over to the other side here, I would have positive 20, or the square root of positive 20, minus 5, and then I'd have negative square root of 20 minus 5. Now when we punch those into our calculator, we're going to get some decimal answers, and that's going to come out to be negative 0.0527, and this one here is going to turn out to be negative 9.472. All right, and I highly recommend that you punch those into your calculator just to check those, but we've now used this method of completing the square in order to solve this quadratic equation. All right, flipping the page over and taking a look at example 3, we're asked to now complete the square to solve the quadratic of the form ax squared plus bx plus c. So one thing to note here is that we do now have a coefficient in front of that x squared term. So we're going to start off by getting our ax squared plus bx terms by themselves. That means we're going to bump over that constant term here. So that's added 8. Next, we need to get rid of that number in front of our x squared. So I'm going to factor out the GCF of 2. That leaves me with x squared plus 10x. And I'm going to leave a little space right here, because that's where we're going to complete our square, is equal to 8. All right, now I can complete the square because I have my x squared plus bx term by themselves. So half of b, 10, my b value is 10. So half of that is 5. 5 squared is 25. So I'm going to put 25 in here. Now, to the right-hand side here, I need to add not just 25, but 2 times that 25, because the 2 is out in front of that parentheses. So I need to add 50 to the right-hand side. All right, so this leaves me with 2 times, and now I'm going to condense this down to x plus 5 squared is equal to 58. Now we're ready to solve our quadratic equation. We're going to start by dividing 2 over to the other side. That leaves me with x plus 5 in parentheses squared is equal to half of 58, which is 29. Now we're going to take the square root of both sides, and that leaves me with x plus 5 is equal to the positive square root of 29, and x plus 5 is equal to the negative square root of 29. Finally, we're going to subtract 5 from both of those expressions. And when we do that, we're going to use our calculator to evaluate. The square root of 29 minus 5 is going to give us, 0.385. I'm looking at my notes correctly. And then we have the negative square root of 29 here, minus 5 more, and that's going to give us negative 10.38. All right, so check those on your calculators as well. But those are our 2 solutions for this quadratic equation. 2x squared plus 20x minus 8 equals 0. All right, that's all for today. We will pick it up there more tomorrow in class. It's important that we practice some of this stuff in a face-to-face setting.